Myself, Dr. Amarnath Shetty, professor in the JIT Civil Department, Mangalore. I will explain about advanced survey, the spherical axis. The spherical axis of the spherical triangle value by which the sum of the three angles exceeds 180. Okay. The spherical axis E is equal to A plus B plus C minus 180 degree. Okay, that's equal to tan square 1 by 2 E equal to tan 1 by 2 S tan 1 by 2 S minus A tan 1 by 2 S minus B tan 1 by 2 S minus C. Okay, the spherical axis E is equal to A plus B plus C minus 180 degree. That is equal to tan square 1 by 2 E equal to tan 1 by 2 S tan 1 by 2 S minus A tan 1 by 2 S minus B tan 1 by 2 S minus C. In geodetical work of the spherical triangle of the Earth's surface are comparatively small and a spherical axis seldom exceeds more than few seconds of the arc. The spherical axis in such case can express by approximate formula E is equal to delta R2 sine 1. Okay. R is the radius, delta is the area of the triangle expressed in the same linear unit as R. Okay, this is the spherical axis. Okay, then we'll explain. Okay, the solution of right angle spherical triangle, Napier rules of circular part. Okay, solution of right angle spherical triangle, Napier rule. Okay, the relationship of a right angle spherical triangle are very conveniently obtained from the Napier rules of circular. Okay, ABC is the spherical angled. Okay, angled at C. Napier defined a circular part as follows: the side A to one side of the triangle, right angle. Side B is to other side of the right angle. The complement 90 minus A of the angle A, complement 90 minus C of the side C, the complement 90 minus B of the angle B. Okay, these five parts are supposed to be arranged round a circle in order in which they stand in a triangle. Just starting the side A, we have the order H 90 minus A, 90 minus C and 90 minus B. Then any part considered as the middle part, the two adjacent of the adjacent parts and remain two as opposite part, we having the following Napier rule. Sine of the middle part is equal to product of tangent of the adjacent part. Side of the middle part, the sine of the middle part, okay, product of cosine rule of the opposite part. Sine B, okay, sine B is equal to tan alpha tan 90 minus A, sine B equal to cos 90 minus B, cos 90 minus C. By choosing the different part in the terms of the middle part, we obtain all the possible relationship between the sides and angles. Okay, this is the two figures. We explain 90 minus B, 90 minus A, 90 minus C, A plus B. This already I explained in this one. Okay, sin A equal to how much, sin B equal to how much. Okay, this is the explanation. Okay, these are the components. Okay, the complement 90 minus A, complement 90 minus C, 90 minus B at angle B at of the side C of the angle A. Okay, this is about this one. Okay, now we go for the latitude and longitude. Very important. Any point of the surface of the earth fixed by latitude and longitude of the point. In a figure 3.6, A, B, C, D, E is the equilateral great circle. If we consider the point M on the surface of the Earth, its latitude is measured along the great circle passing through the pole and point M. Such circle is known as meridian circle. Latitude of the place is the angular distance between distance measured from the equilateral equator toward the nearer pole along with the meridian of the place. Latitude angle subtended by a arc mm dash, where m dash is the point of meridian of the circle through the m is the intersect the equator circle. Alpha is the latitude of m. The equilateral circle divides the earth into two halos. The part above the equilateral circle is known as northern hemisphere. Okay, part above the equilateral circle is called northern hemisphere. Part below the equilateral circle is called southern hemisphere. Okay, the angle of the point measured above the equator, okay, the point has northern latitude. If the angle of point below the equator, southern latitude. Okay, this one. Longitude is a place angular distance between a meridian of the place and the standard of prime meridian. The meridian to the Greenwich is internationally expected as the standard zero meridian. A point may lie to the east or west of the standard meridian. The longitude can be east, east longitude or west longitude. The point M lies at the east of the standard meridian and thus has the east longitude. The longitude is the angle between two meridian planes. Okay, thus beta is the longitude of the M. A parallel of latitude is the smaller circle having P as the pole axis. All the points of the parallel of the latitude having same latitude. Okay, in the figure 3.6b, MBA is the parallel latitude. Point M and B have the same latitude. Okay, this is the equator plane. Okay, so southern latitude. Okay, north latitude. Okay, west latitude, east latitude. Okay, zone of latitude, parallel of latitude. These are the figure. This is the beta. Okay, this is the equator, an equator plane. Okay, this we can see the latitude and longitude. Okay, now we go for the next crystal sphere. Very important, a crystal sphere. The millions of stars that we can see in the sky of the clear cloudless night are the varying distance from us. Since we concern with their relative distance rather than the actual distance from the observer, a exceeding convenient to the picture of the star distributed over the surface of the imaginary spherical sky having its center at the position of the observer or the earth. This imaginary sphere on which the crystal bodies appear to lie or to be studded is known as crystal sphere. The radius of the crystal sphere may be of any value from few thousand meter to few thousand kilometer since the star very distant from us. The center of the earth may be taken as the center of the crystal sphere. Okay. The earth rotates from the west to east. It is the convenient to consider the instant crystal sphere is moving from east to west with the earth motion halted. The point of view of astronomical survey, the distance of the crystal bodies are not significant, but the angle at which they are seen significant. Our interest also limited to the sun and a few fixed stars. Okay, the millions of the stars we can see in the sky on the clear cloudless night are all at varying distance from us. Okay, since we concerned with their relative distance rather than the actual distance from the observer, the exceeding convenient to the picture of the star distributed over the surface of the imaginary sphere sky, having its center as the position of the observer of the earth. The imaginary sphere on which the crystal body appears to lie or studded is known as crystal sphere. The radius of the crystal sphere may be any value from a few thousand meters to few thousand kilometers, since the stars are very distant from us. Okay, the center of the earth taken as the center of the crystal sphere. Earth rotates from west to east. It is convenient to consider crystal sphere moving from east to west of the earth motion metric. Okay, this is about crystal sphere. Okay, now we go for astronomical terms and definition. Okay, one by one we will go. Okay, first one crystal sphere, second one zenith and nadir, third one crystal horizon. Okay, next one terrestrial poles and equator. Okay, next one crystal poles and equator. Okay, next one sensible horizon. Okay, next one visible horizon, vertical circle, observer meridian, prime vertical, latitude, okay, whole latitude, altitude, co-altitude or zenith distance, azimuth, okay, mm, declination, co-declination and polar distance, hour circle, hour angle and right ascension, okay, right ascension, RA, okay, elliptic and soletic, okay, elliptic and soletic, okay, then uh, equilateral point, okay, then north, south, east, west direction, okay. These are the we have to explain one by one about this astronomical okay definitions of astronomy which is there in this one. We have to explain. Okay. Now, okay, we